In this video, I'll demonstrate how to validate the curve fitting functionality performed in myassays.com with Excel. We'll validate the analysis performed in the myassays.com assay by reproducing the analysis independently of the online myassays.com service in Excel. The intention is to provide transparency in the methods used, which is useful for comparison and validation purposes as might be required for customer quality requirements. I have opened the general 4-parameter logistic curve assay on myassays.com. We can see here the measurement data, microplate layout, and standard concentrations. These elements will be used to perform the curve fit and calculate results. I've replicated this same information in our validation spreadsheet. Opening the spreadsheet, we can see the plate layout matching the layout on myassays.com, as well as our raw measurement data and the standard concentrations. Let's go ahead and calculate our results in myassays.com. I'll press Calculate, and once our results have been returned, I'll open the report. Here we can see the calculated parameter values, followed by our curve chart, curve data table, and sample table containing the concentration results for our control and unknown samples. I'll select Export to Excel from the Output options to open and save these results in Excel. Next, let's configure the analysis in Excel. The first step of my analysis is to perform a blank correction. My blanks are housed in well G1 and G2, so I need to subtract the average of these values from all other samples on my plate. To do this, I'll click in the blank corrected matrix and type equals and select the corresponding well from my raw data matrix. Next, I'll enter minus the average of G1 and G2. I'll also press F4 to denote this selection as an absolute reference. This will allow me to drag the formula across the remainder of the matrix. Now our blank correction step has been performed, and the next step in the analysis is to perform a 4PL fit. It's not easy to perform a 4PL curve fit in Excel, so we'll use the MyCurveFit XL add-in. Additional validation content for the curve fitting performed by the MyCurveFit XL add-in can be found in the videos linked on screen now. You can also access these videos from the links in the description. I have an additional table here to house my calibrator X and Y values. I've already added the standard concentrations or X values to match those on myassays.com. Now we need to calculate the average blank corrected value for each standard. So I'll enter equals average and select the first two wells containing the blank corrected values for standard 1. Because my standards are in a vertical line, I can drag this formula down to continue calculating the average Y values. Below my calibrator values, I have a table to house my 4-parameter logistic results. I'll click in the top of this table and enter equals mycurvefit.4pl. I'm prompted to enter the calibrator X and Y values, and we can optionally add additional formatting. I'll enter a value of 1 after selecting my calibrator Y values, so the orientation for my parameters will be vertical. Pressing Enter applies the function, and you can see here my parameters have been calculated. A chart is not automatically generated when calculating curve fit parameters with the MyCurveFit XL add-in, but if you'd like to learn more on how to create a curve chart, please see the associated video. Next, we need to calculate the concentration for each of the samples. I've added another matrix titled Concentration here to house those results. The concentration is our X value, so I'll use the MyCurveFit 4PL Calc X function, which will use the 4-parameter logistic curve equation and the calculated parameters to return the X value based on the entered Y value. Typing equals MyCurveFit and selecting the 4PL Calc X option, I'll first highlight the A, B, C, and D parameters, pressing F4 to denote an absolute reference, and then highlight the Y value, which is the corresponding blank corrected value. Pressing Enter returns the calculated concentration, and I'll drag this formula to fill the remainder of the matrix. Now let's compare the results between myassays.com and Excel. Looking at the parameters calculated in myassays.com, you can see they match the parameters calculated in Excel to 2 decimal places. Note that sometimes the A and D parameters can be flipped, and as a result, the B parameter can be negative, but these values will remain the same. I've added a sample table sheet to this spreadsheet, which uses cell references to organize the results into a single table for easier analysis, such as averaging the concentration values to simplify the comparison. Looking at the results for our samples, you can see the results of the myassays.com analysis match the results calculated in Excel to 1 decimal place. The results beyond this level of precision may vary due to slight differences in the methods used across these implementations. When comparing fit results from different implementations, it's important to note that all nonlinear fitting models inherently involve some degree of error, which can lead to minor differences in outcomes. A key metric for assessing how well the model fits the data is the R-squared value, where values closer to 1 indicate a better fit. Thus, when comparing fits, it's helpful to examine the R-squared value. In this case, both implementations produce high and consistent R-squared values, indicating a good fit in both instances. If you'd like to download this example spreadsheet for further use and validation, you can do so from the below link. Some of the benefits to using myassays.com over analysis in Excel include pre-configured protocols for typical analyses and commercially available kits, the ability to quickly and easily change the layout without the need to update cell references. You can easily visualize and interact with the curve, including quickly and easily flagging and removing outliers, easily share your results with colleagues, and there is no specialist software to install. If you have any questions about validating the curve fitting performed on myassays.com, please email us at support@myassays.com.